Thank you. Good morning, everyone. Let us dive right into the session, and I guess all of us are back with a pack of energy and enthusiasm. But what exactly are we talking about today, Prasanna?
Well, let me give you a hint about that. Building design and construction process are quite challenging, sophisticated, and complicated. Schedule for the design process may be quite tight, and hours to be spent on the design are unlimited.
Oh, wait, I guess I know where this is going. Of course, the structural is an essential element, defines the shape of the architectural space. The structural system is not exposed but still has a significant influence on the form of the building. And now, to know about the challenges faced in the construction of these architecture marvels, I would like to invite Professor Ram Kumar to introduce the speaker of the day. Over to you, sir.
So, could you please unmute?
Thank you, Prasanna, and thank you, Chandani. It's a pleasure to introduce the speaker of the day, Engineer A.Soundararajan. Engineer Soundararajan is the head of the engineering division, Eversendai Construction Private Limited, Chennai. He has done his bachelor in civil engineering from Institute of Road and Rail Transport Technology, EROAD, and Master of Engineering with specialization in structures from the College of Engineering, Bindi, under Anna University, Chennai. He has many publications and achievements to his credit. His paper on modulus of core reaction, approach to the buckling of sandwich plates, is published in the International Journal of Structural Stability and Dynamics, a scientific journal published by World Scientific Singapore. Engineer Soundararajan delivered key paper presentations in 3 subsequent national conferences on structural steel held at Rourkela, the steel city. He has to his credit 17 papers which were presented in national seminars and has won the best technical paper awards from the prestigious institutions like IITM, NIT, Anna University, and Annamalai University. He is also a member of American Institute of Steel Construction. Engineer Soundararajan has pioneered in design and construction practices of steel structures and successfully handled more than 3 lakh metric tons of structural steel detailing and design. He provided value engineering and smart solutions in lifting sky garden of 1,000 metric tons to a height of more than 100 meters. In the capacity of the head engineering division of Eversendai Constructions Private Limited, he is responsible for design and engineering efforts in India, Malaysia, Singapore, apart from assisting the activities of Middle East. Some of the prestigious projects he has handled or he is handling includes the Statue of Unity, which is the tallest statue in the world. One Avil is a Dubai's under construction tower which holds the longest cantilever in the world. The Season skyscraper, which is a 72-story skyscraper, and Zima power plant, which has consumed 9,800 metric tons of steel. He is also into KL 118. It's a 118-story building with 35,000 metric tons, also known as Medica 118 in Kuala Lumpur, Malaysia. This is the second largest tower once completed. It's the second largest building in the world, tallest building in the world, and the first in the Malaysia. Mr. Soundararajan, with his vast knowledge and experience, is here to provide us insight into the understanding of challenges in construction of architecture marbles. Sir, I here welcome you on behalf of the Woxsen family to take up the stage for this session. Thank you, sir.
Thank you, Ram Kumar. And I'm happy to be part of Woxsen conferences. Am I audible?
Yes, sir.
Yeah, fine. So before wasting all your times, we'll go into the seminar. This particular seminar will be of 1 to 1.5 hours. I will try to put the maximum effort to minimize all your.
Sir, just a moment. Sir, Soundararajan, sir.
Yes, sir.
Sir, please don't minimize, sir. Take your own time, sir.
Okay, fine. Maybe if you have scheduled other functions, maybe I have to speed it up sometimes.
It's all right, sir. No problem.
Fine. Okay. So today what we are going to do is we are going to see how the architectural marvels are being built. Normally, there is always enmity between architect and structures. Normally, since the architect are always the person who dreams, and the structural engineer is the person who always makes it to happen. So the reality between the dream to the reality is always will not be smooth, but once it made smooth, then the marvels will become. Okay. So before I get into the presentation, I will give a brief about the company which I belong to. So this company, Eversendai, is started in 1980. The managing director is A.K. Nathan, Yelumalai Karpaya Nathan. So he started in 1980s as a steel construction company. It is basically in Malaysia. I'll just get into the video. So instead of going into the PPTs, I'll just present through this video about the company. So these are the structures which we built in the past 35 years in the world. Normally we belong to tall towers. That is our core strength. So we undertake integrated structural steel works, composite structures, mechanical installation works, and offshore processing units. So these are some of our power plants. We normally adhere to safety first, quality, and schedule, and total client satisfaction. So we have fabrication facilities all over the world: Malaysia, Dubai, Qatar, Al-Qasis. So these are some of our fabrication photographs. So these are the projects which we have done in Malaysia: Petronas Tower and the Sky Bridge, which is connecting the left and right tower, Putrajaya Convention Center and the KL Tower, Telecom Building. This is KL Airport, KL Central Station, the metro. These are the power plants which we have done in Malaysia, and we are the first to do 1000 megawatts power plant. And these are the projects in Singapore. The Republic Plaza, currently the tallest Singapore building. Tuas checkpoint, which is connecting the Malaysia and Singapore. This is Changi Airport, which is the current Singapore airport. Thailand, Philippines, Hong Kong Airport. And these are the projects in India: Mumbai Airport and North Chennai Power Plant, Yamco Power Plant, Marathon Tower in Mumbai, Worli Tower, which is 85-story building of Oberoi. This is in Saudi. These are the projects in Qatar. This is the Qatar International Airport, New Doha International Airport. This is another crazy project, Qatar International Museum. So these are in Abu Dhabi. A District Tower, Cleveland Clinic. Airport of Abu Dhabi. And these are in Dubai, where the major projects of Dubai we have done. Dubai Mall, the world's biggest mall in the world, Dubai Mall. Ar.Syed Hotel is the first project which we have done in Dubai. And the Burj Khalifa, where we have covered the tallest tower in Dubai. So with 35 years of experience, we are currently stepping into the next frontiers. Yeah, today what we are going to do is majorly I divide into two chapters, which is first is since we are there with the student community, I want to have a bit of awareness. What is that currently architect and we as students we are aware of, and then we will get into the challenges. Normally, what is the role of the architects? Architects creates, improve, protect environment in which we live. So this is the major role of an architect. We plan, design, and oversee the construction and take care of the maintenance of the building. And it everything what we do as an infrastructure, house, towers, dams, everything is the part of architect. But how far we are doing this? Whether it is 5 years before, say 125 years before 125 years, we have the metallic era, we have this Eiffel Tower and the Statue of Liberty. So all these things we have built before 125 years. Whether this 125 years is the one which we have done the architectural marvels. No, we go further beyond, we go further to 150 years where there are marble structures which we have created. So the world famous Taj Mahal, which we have done 150 years before as a world marble. We have collected marble stone from Rajasthan, Tibet, Afghanistan. Even the dome, if it is, if you can see the dome, the main dome is about 55 meter and the height is about 35 meter. When we go further far away, say 420 years, we have built townhouses. So we have history of townhouses in Yemen where 7-story building has been constructed by means of brick itself. So we go further beyond, say 840 years. 840 years, currently we have this Pisa Tower, which is built before 815 years. Currently, the deflection has been controlled. Previously, it was 4 degrees. Now it is now stretched back to 2 degrees. But the architectural marvel didn't stop. We go beyond to 1,000 years, where we have used stone and wood as the material. Tanjavur Temple, it is of 1,000 years old. It is completely made of stone. The main kumbam, if you take the right top corner, the main kumbam, it is of 80 tons, a single stone. It has been brought and it has been built. The wooden bridge in China, it is about 1,000 years and still it is there. Further, we go beyond and it is about 2,000 years when we see the Grand Anaikut, which is in Tamil Nadu, which is about 2,000 years before it has been built, and still the marvel is there. We go further beyond 2,300 years, the Great Wall of China. So we people, we would have seen the Game of Thrones, where there is about huge high walls of 700 feet or 700 meters long. So similarly, before 2,300 years itself, there is wall has been built between countries to protect the country from invaders. 2,500 years we passed upon. We can see from Greece, marble stone marvels of about size of to a height of 70 meters. They have built-in marbles. Further 4,500 years, we go into pyramids, where it is every 2 meter by 2 meter. It is the best construction, where it withstand all the natural calamities and it is still undisturbed. 5,000 years. So we have the Stonehenge in England. All the prehistoric monuments are there. So it is a culture of 5,000 plus years. We as engineers, we as architects, we have been living and we have been giving wonderful monuments to the world. So despite of all these things, okay, normally your professors or even your parents will talk about those days are the golden days. Okay, even if you graduate and you cross upon another 20 years, 25 years, you will tell no. The era when I lived or the era of my grandparents is the best. Since currently nowadays we mostly we don't think or we don't put across our pen and paper and on the drawing board we draw. We normally get into some Google, some softwares where our productivity and our thinking capability get reduced. So whenever the architects, we feel it has to be error-free, the thought process has to be complete when we sketch down itself. So this is a graph where we can see when there is a mistake happened. When it is a design phase, yes, the cost to correct is minimal. When it's the construction phase, it is huge. When the building is put into the purpose, then we cannot correct it. It will go into litigation. So the complete thought process has to be done before the design phase itself. Now we will get into the challenges. Now, yeah, architect has been made and the architectural marvel has been created, sketched out. Now, what are the difficulties in bringing out this marvel into a practical aspect? So I divide this into 3 phases. One is a detailed design challenges. So as an engineer, we have to do a detailed design where there are challenges or there in detailed design phase. And the next one is the fabrication. There are difficulties in fabrication and there are difficulties in erection. The first we will see the detailed engineering difficulties. So if you can see the difference between the skeleton and the finished structure. Fine. First one is the geometry and setting out. Normally, the geometry, when we set out, geometry is never orthogonal. Whenever we want to build some marvels, it will never be orthogonal. You can take anything, even when Ram Kumar talks about the first structure he talked about is the Statue of Unity. Statue of Unity, there is no symmetries at all. Everything, the nose is different, the ear is different, his dhoti is different, everything is different. Okay. So now we come into the geometry. We will take an example of Kapsark. Okay, it is in Saudi Arabia. It is a mosque. And this is the architectural intent. I will just run through a small video how the architect developed the structure. It is by means of droplets of rain put together. This is basically a mosque. It has a different types of columns and nothing is symmetrical. It has natural lights coming in. So we will get into, this is the stage where during the construction, you can see the skeleton. This is a cantilever. This cantilever is about 15 meters cantilever. So the geometry plays a big different role. So the geometry has to be derived from the major architectural model, say that is where building interface modeling comes into picture. There should not be any differences between the architect's thought and the real-time construction. And the nodes, normally this is what I want to emphasize. Normally there should be a vision about when we blow up some joints, during the construction purpose, there can be a bolted joint, there can be a welded joint. So what type of joint we require, which member has to go first, how the architect wants, whether it is structurally the intent has been perfect or not. So this multi-planar joints play a very big role. And the connecting of these multi-planar joints. Now, this particular structure, whatever you have seen, it is that it is supported by means of bearings. And the bearing supports are highly critical. And these are some of the connections where the members are different. You can see the supported member of I section, it is of a different size to the connecting supported member. So the connection is highly complex. I will just put an example of another dome structure. Yeah. So this is a dome. This is again a mosque. This is a dome structure which it is again in Saudi. The difficulty in constructing of a dome is normally a structure is intended to deflect. There is a difference between the deflection during the construction and deflection during the purpose. When the structure is being deflected during construction, so that means I have to give a pre-camber. Pre-camber is nothing but inverting my deflection. Say, for example, my structure is sorry, say my structure is deflecting by about 50 mm. From my theoretical point, it is deflecting 50 mm. What we will do is, during the construction process, we will construct it with an upper camber of 50 mm. So that once it deflects, it will come to the normal position. So that is called pre-cambering. So when we do a pre-cambering, what is the problem is, in a dome-like structure, dome will have a proper diameter and it have a proper surface dimensions will be there. But when we do a pre-camber, and this pre-cambering is done only on the trusses, you can see the trusses which are running on the peripheries and at the centers. These trusses alone will be lifted up. So the pre-cambered structure will be highly complex to arrive at. So this is the similar structure where there are supports and the pre-cambering has been effected. So at every node, there will be the pre-camber will be defined, and then only the geometry will be arrived. This geometry and the original geometry will have a difference. And the next challenge is the other vendors. So apart from the structures, we have MEP pipelines which will be running through. There are rainwater pipelines. So all these things has to be coordinated. So there is a small video of how the MEP provisions have been incorporated. So this is a 3D model. During the 3D modeling phase itself, all these plates and the pipes will be modeled, and the required openings will be provided. So unless we do a building interface modeling, we cannot do it properly. So other disciplines like inserting of plates inside the core walls. You can see these are shear walls. Normally, shear wall is a structural element which is provided in multi-story building, especially to control the drift. Normally, the structure will deflect H over 500 or H over 400. That means if a structure is about 50 meters, okay, so 50,000 divided by 500. So the structure can deflect up to about 500 mm, it can deflect. So those type of deflection control mechanism will be done by means of providing shear walls in between the structure. So these things also has to be coordinated. You can see the shear walls and the rebars, highly congestions were there. So all these things has to be coordinated during the design phase itself. And also the facade. So this is another example of deck. Now currently we are using for a deck span structures where composite slabs are there, where metal decking, trapezoidal metal deckings were there. So trapezoidal metal decking also has to be coordinated. So these are few challenges which we have to kill during the design phase itself. And during the fabrication time, we have, as we see in the design phase, the multi-member nodes. This is another crazy structure which we love. This is one project where it has been awarded to another contractor, and that contractor could not build, and even the Qatar Queen herself was the project manager, and she was overlooking all these construction. This is Qatar National Museum, and it is a very crazy structure. I'll just try to run that video. Okay, this one I'll just see that video. This is by means of flower. There is a lotus flowers will be there. Sorry, let it come. The architectural intent for this particular structure comes from the desert rose. If you see in the desert, this is the type of rose which will be available. So based on that, that particular structure has been arrived, and it is one of the highly complex structure which in my lifetime I have seen. You can see the concept. There are vertical, you can take the left bottom, there are vertical disc were there, and over the vertical disc, there will be a top roof disc will be connected. And this will be of every inclination will be there. And this is from real-time desert rose, it has been arrived at. And these are the joints. At one particular node, about 64 joints were there. 64 members has been connected in one particular node. So you can see the highly complex multiplanar nodes. And the next problem in term challenge is the achieving the curvilinear geometry. So when you take any curvilinear structure, some structure we can curve it by means of roundo machines and we can round it off. But sometimes the multi-dimensional, multi-angular members we have to do in segments. You can see at the top where you can see small segments has been welded together. And this is that particular portion of Abu Dhabi roof. And this is another crazy structure in, this is a YAS canopy, where this is again a challenge in terms of bending and curving the members. And it is again a hollow structure. And how we ensure the geometrical fit. Normally we talked about challenges. So at site, we cannot take any chances whether it will fit properly or not. So what we will do at the fabrication facility itself, we will go for a pre-assembly in terms of the fabricated structure. You can see the human beings, the fabrication workers who are standing. Okay, based on that, you can see the size of the structure. This is about 190 meter length curved structure. This is for Qatar airport. So this is again for Qatar airport. You can see this is the curved roof, the main terminal roof structures. And this again for the Qatar National Museum. This is in the factory itself. Everything will be verified. The fittings, everything will be verified. This is on. This is in India, where we have made the complete structure, whether it is the pre-assembled and the verification of all the joints have been made. This is the column structure, whatever you have seen the previously, we have inserted the rainwater pipes, everything. So that also the pre-assembly has been made at the site. So this is how the pre-assembly, before the pre-assembly, the structure has been made, the pipes have been inserted, and even for the electrical works, the conduits has been made. And these are the facade cleats which has been made during the fabrication itself. And whenever there is a architecturally exposed structure is there, that means that it is not going to be getting cladded. Then that means it is a special type of preparation has to be made for the structural steel. So first it has to be blasting has to be done. Blasting, it is of SA 2.5. SA 2.5 is a Swedish code which talks about the surface toughness and surface finish category, and the filler application will be made. then application of the primer paint, then intermediate mid-coat paint, then the finished coat will be made and the structure will be shipped. Now we have seen all the challenges, whatever we have seen during, it is all in controlled environment, where in a design phase, where we sit in a air-conditioned room, where we can think to our own extent and we can do. And fabrication facility, yes, it is under a roof where we have enough time to do. But in erection phase, where it is in the tall structures, we will be working at a height of say 800 meters, 1 kilometer height, and it is a curved cantilever of 50 meters. So we cannot think. So that means the erection engineering, before the erection itself, there has to be a proper engineering has to be made. So these are the few failures which we have come across in India. There is about Kolkata, around 5 years before, there is a Kolkata metro rail bridge has been collapsed. It is a structural steel, has been collapsed during the construction stage itself. This is another building, multi-story building. It is a concrete building. It is also collapsed during its construction. This is just 2 or 3 kilometers away from my residence. So what is all these things I emphasize is during the construction phase, we engineers has to make a thorough study before going into the construction itself. So I will just briefly explain to the architect field, since it is not your cup of tea, but you have to understand the basics. For example, this is on the left side, you can see a portal frame. That means it's a stable structure. At point A, it is fixed, and point D, it is fixed, and there is a column between A to B, D to R, D to C, and B to C, we have a beam. So the structure, if this present structure, it is completely stable and there is no issues. But during construction phase, how it happened? The beam will be of say 15 meters, it will be cut into 2 during the transportation. That means there will be a splice will be there at the middle or at the center. And during lifting, it will be lifted at a single point and lifted at a 2 point. That means the middle portion, the middle diagram, if you see, the support is there at the ends. But when you lift it at the top, it is not designed or intended to be designed in that particular purpose. So this is a brief, and during, if you don't understand what is this, we will elaborate it in the subsequent slides. And this is a pre-camber which I try to explain during the detailed design phase. So at the top, if you see, this is the original architectural intent, and during the permanent condition, there is a deflection. The structure is going to come down to about 13 mm, or say 50 mm, it is going to come down. What we will be doing is, we will do an upper camber. And this upper camber, by means of upper camber, once it deflect, it will come to the original position. Okay. We will get into some buildings. I take you into 4 buildings, how it has been engineered. What are the challenges in engineering while we construct? The first one is going to be the Gate District Tower. So this is of 240 meter tower, 66 story, and the curved dimension, it is about 303 meter is the bridge dimension. And you can see the bridge, inner and outer. The structure has been designed, and after it comes to the construction phase, the structure, I'll just explain, I'll just come back to here. Okay. If you see, the structure is, as I explained during my 2 slides before, now you think it is a column. Okay. It is designed by means of, if the top hat portion is there, then it is stable. If the top portion is not there, then it will be behaving like a cantilever, free cantilever. So until the top hat is completed, it is a cantilever. So during the construction, those particular deflections has to be controlled, and this particular tower has to be lifted from the bottom. So based on the analysis, there are some members has to be strengthened. There are different types of analysis has to be made, how it will behave during complete cantilever and during the lifting, how it will be made. So based on that, the previous designed structure has to be strengthened whenever it is required. And this is the conceptual arrangement. So if you see the structure, it is not straight. The towers is not straight. The towers is of tapered portion. The first lift is of on the left side, it is 750 tons, and the center portion it is 750 tons. And the last, there are two lifts are there. One is 150 and 300. So there are totally 4 lifts has to be made, and this one has to travel to about 200 plus meters. It has to travel. So this is how you can see the human beings, the working personals have been there. Even doing the lifting, there will be persons will be sitting over there. They will be checking whether the joints are there proper or not. And this is the real-time photograph when the lifting happens. So the structure design during the construction phase is different from the structure during the main stage. So the erection engineering plays a very important role, and the concept how we has to erect has to be thought during the even the architectural intent design phase itself. So the last cantilever at the right end, it is lifted in 2 pieces. One is 150 tons and another is 300 tons. So this is the completed tower. So all the lifts has been carried out. And this is the structure once it lifted. I'll just play a small video. So you can see how much is the wind acting. You can see the trees, whatever has been planted has been there, and from the day now it is evening, it has been shifted. A lot of winds and the climatic change you can see. Next day, next tower lifting has been happening. So we have to design for all these winds. You can see the last cantilever has been lifted. So this is the Gate District Tower. We will take another interesting one, ADNOC headquarters, where the structures with the top open or there are very few. The gap between the tower and the top roof structures. Okay, so this particular structure, when it comes to Eversendai, the structure has been completed, and there is no thought process of how to build the top structure. It is not there, and the structure is built in a highly traffic road, and there is no space, literally no space to pre-assemble and to erect. So this the structure has to go at the top. It is about 2,100 square meters. 67-meter length and 32-meter width, and the total structure is about 1,400 tons of structure has to go up. It is basically consists of 3 trusses, 1, 2, 3. It is about 3 trusses. So the concept what we have arrived is, you can see the 3 trusses at the right bottom. The 3 trusses has been assembled one over the other, and it will be lifted. So once it lifted, it is not getting into the structure. It is lifted and it is there away of the structure. So once it lifted, then we have to take it into the structure. Then we have to insert another piece. If this piece is there at the original condition, then the lifting will be a problem. So this has to come out. Then after that, it will be removed from the vertical jacking and the horizontal jacking will happen. Then it will put into position. So this is the real-time photograph. You can see the bottommost piece, and these are the sliding rails will be there. And for the vertical lifting, you will be having a vertical jacks, and horizontal lifting over the side rail, which you are seeing on the right side. At the side rail, there will be a horizontal jacks will be pushed. So these are the 3 trusses which are assembled one over other. This is basically because of the space constraint in this particular site. So the first truss has been getting lifted. These are the lifting photographs. Now the lifting went to the top. So now you can see in the bottom there is no truss to receive this one. So the bottom sliding truss now to go below that. So about 5 meter it is sliding outside, and the top portion is slide 4 meter, and the bottom portion is slide about 5 meter. Now it is getting ready for the horizontal jacking. So it is been slide and kept into position to about 32 meters. So similarly, now the second set of trusses are coming in, and the third set of trusses. Then the infill beams will be erected. So just to play a small video, the real-time video of this. You can see the first set of trusses has been lifted. So every time the survey will be made, whether the structure is behaving proper, whether the deflection is proper, whether the hindrances we have cleared is being safe. So whether the structure is deflecting any locations, whether the joints putting any sound. This is the horizontal jacking. The sliding truss has been put about 5 meters. It has been slided horizontally to receive the piece. Now it is detached from the vertical lifting, and the horizontal lifting is on process. So every time application of the grease will be happening and the lubricants, whatever required will be applied to reduce the friction. So once it is made, so similarly the other two will have been done. So the next one is capital gate. Capital gate is another interesting structure where it is the having a Guinness record for most inclined building. So Pisa, we have seen 14-degree inclination. Now it is put forward to 5 degrees. This particular structure has been constructed and it is of 18 degrees inclination. Carries the Guinness record for the inclined building. It is completely a diagged structure where in India there are few diagged structures were there, but not of full swing. This is the beauty of a diagged structure where there are two types of diagonal structures. Diagged structures are there. There are internal diagrams are there. External diagrams are there. I'll just explain that. So these are the external diagrams which forms the shell. There is no columns in this structure. Instead, there is a diagram. It forms the facade supporting structure and it is architecturally exposed to. You can see the external diagram. And these are the complex joints. This is the lifting of a diagram piece. And these are internal diagrams where in the inside, instead of a core, we have an internal again a steel structure. So this is the construction of this internal core. There is external periphery also diagrammed and internal core wall is also diagrammed. The external diagram is of SHS and this is of CHS, that is circular hollow section, that is square hollow section. So you can see the planar view during construction time. Now these are the embed plates which are fixed to the core wall to connect these particular trusses. So this is the construction time. Sorry for that. So this is a real-time construction photograph. In this particular structure, the core wall is straight. Only the structure and the facade and the diagrams has been made in the inclined way. You can see the core wall. The core wall is straight. But similar to the pre-camber, here also the core wall has been built in a negative camber, negative positioning of about 500 mm. It has been constructed. Then during the construction, it has been straightened. And the middle portion, you can see there is a swimming pool there at the middle. This also acts as a counteracting force for the inclination. Now the previous projects we have seen is of overseas. Okay, fine. So there are many there in India. So I will take one in India to explain about. So this is in Kolkata, which is Atmosphere. This is by owned by Forum. This is a 32-story building, and it is owned by 32 plus 32, 64 owners. And the top tower, it is a private one. It is not a public. It is a private one. It houses all facilities. It has its own swimming pool. It has golf clubs. It has spas, hotels. Everything is there, and it is a private one. It is not open for public. It is for the tenants whom are staying there. There are about 64 tenants in the total structure. And if you take the bridge is visualized by as a cloud. That is why they called Daya. Daya means cloud. So it is similar to cloud when a cloud stands in between the structures. So that is how this particular structure has been made. So the bridge is about 96 meters and it is about 27 meter wide and to a height of about 20 meters. The total structural weight of this particular bridge is about 2,200 meters tons. So this is the particular one. So you have seen the Gate District Tower, how it has been lifted. So similarly, it has been divided into three segments, N segments in Tower 2, N segment in Tower 1 and the middle segment. And the total structure is sitting over a 4 number of bearings. So to support the bearing, there is a bearing support structure which is about 210 tons to support the bearings. So the bearing itself is about 15 tons. You can see the lifting of bearing. So this is the bearing. So similar to this, there is about 4 numbers of bearings are going to get erected. So you can see there are 2 bearings on one tower. Similarly, on the other tower, there will be 2 bearings. And the end portion in the each tower has been erected by means of temporary towers. Since without temporary towers, it is not self-stable. So with temporary towers, this has been erected. On the top, you can see the orange color member. It is called cat head. Cat head means it is a structure which will support the stand jack. By means of this particular structure only, we are going to lift the middle segment. So this is the right portion. So similarly, the left portion also has been made. So now the jacks has been fitted at the top. So now we have to see what is that happening at the bottom. At the bottom, we will be assembling the middle portion. So middle portion, again, it needs a temporary tower. It cannot be done at the slab itself. These are the temporary towers over which the middle structure is going to get erected. So each and every piece, normally in erection engineering, we will be going into the minute details. So what is the piece? For example, this particular assembly, whatever we are discussing currently, this is of 3 tons. So this is going to be lifted by means of one particular tower crane. There are about 3 tower cranes are there. This particular tower crane is going to lift, and this tower crane is going to lift this particular piece at a radius of 35 meters. At this position, the tower crane capacity is about 9 tons, and we are going to lift 3 tons. So that much for each and every assembly, the crane study and the stability study will be made. So this is the bottom card of this particular structure, and the top card is now erected, and the arch segment getting erected, and totally the middle structure is erected now, and it is hooked, and the lifting commenced, and the lifting is on process. And there are at every 5 stories we have wind arrestor frame. For example, Kolkata and all is subjected to a huge cyclonic wind. For example, if any unprecedented cyclone comes, okay, we cannot leave as it is. It is like a swing or a pendulum. If you leave, it will just swing to about 100 meters or 1 kilometer, it will just swing. So we have to arrest it temporarily if there is any natural calamity, unforeseen natural calamity comes. So there are wind arresters will be positioned at 12th floor, 18th floor, and 23rd floor. So the lifting is on process, and the lifting has been made. And once the skeleton has been made, then the finishing and over the structure, the other equipments, the claddings, everything will come into picture. I'll just run a small video of this particular lift. So all these structures, whatever I have explained, will be part of National Geographic channel. Also, you can get into the website and you can get into more of these one. So every time during lift, there will be survey will be there will be a pause will be there, whether the structure is behaving as proper. There will be checkings going on the stand jacks, whether the stand jack is running proper, and the joints, whether any bolts getting loosened up. So there will be people at every critical joints, there will be people will be there, and there will be a central station where the engineers who are responsible for the lift will be there. Behind this building, you can see some dome structure that is called Science City. People, if someone is from Kolkata, they know Science City. There are survey stations positioned in Science City so that it can be the surveys, the total station survey can be made. So it took a day time for the lift to happen. So this is one of the recent photographs of atmosphere structure. Now I move on to the conclusion part. So on to the budding engineers, what you learn about these particular curves. These curves are part of our engineering life. The first one is on the core field. When we step out, okay, when we are there as a core group, say as a structural engineer, as an architect, over the years, our salaries will get increased. When you are starting, okay, your salaries will be very minimal, okay, and it will be like a stipend. But over the years, it will be steady and it will be increasing progressively. But there are lucrative IT companies will be coming into there. Infosys, everything will be there where they need just a basic engineering course. It can be an architect, it can be any degree they need, but the salaries will be huge during the initial phase itself. But it will be ups and downs. Whether you have seen any IT engineer above age 40, there will be very few. Then where are they? People whomever joined before 25 years, where they have gone? There is no job after 40 years. There will be, if there is there, only few. They have to quit. And the initial period only the IT field will have. But when we get into our core field, it will last long ever. So what you have to develop, okay? Challenges are highly open in the industry. And the textbooks will not provide the exact solution. What you have to do, you have to take concept from the books. And you have to think laterally. Whenever you have an opportunity to get into an industrial exposure, you have to get into that. You have to take a proper training. And whenever you have a professor or whenever you are about to see a practicing architect, you have to gather as much knowledge as you can. Since many things will not be available in internet, that is, I'm sure. You have to discuss with them and you have to practice and you have to get it. And most important, in any career, any field, okay, money alone will not give any satisfaction. Apart from money, there are a lot of things. Once you do with the pride, you can see the structure. That is more than enough than crores and crores of money. Whatever you earn, okay, you are going to eat only 3 times. You are going to put maybe 2 or 3 dresses per day, okay. So don't look upon money, okay. Think of your goals. Always be crazy about your profession. Always think this one I have to make it as a marvel, okay. Just give importance to your ethics, okay. No need to worry too much, okay. The God will take care, okay. So nobody can go back to and start a new beginning, but anyone can start today and make a new ending, okay. So with this note, I thank you everyone for the opportunity rendered. If you have any questions, you can ask and you can email to. All over to Ram Kumar and Chandani. If you have any questions, you can ask.
Thank you very much, Soundararajan sir. It's a great lecture. I hope our students have a great opportunity to get introduced to new terms like the diagrade, the exoskeleton, and we are very much excited about the Capitol Gate building, the Enoch building. So these are buildings where the challenges are more during the erection and execution stage. So also you have informed us, our students, about the importance of building interface management. Builder interface management gives us a great opportunity to check the building before execution and to avoid great losses during the erection and commission stages. So we are also introduced about the new terms like the stand jacks, the lifting and sliding machinery mechanisms, and the difficulties in the execution of tall structures. So I hope our students will get a brief about this and they can implement their implement your advices and your knowledge into their upcoming structures when they go out of the Woxsen College as great architects. So, sir, we have some of the questions from our faculty and our students. And before that, I would like to ask Engineer Ramesh from Dubai to speak about his queries. Sir, Ramkrishna sir, Ramkrishna sir.
He is from no, Eversendai company.
Okay. So is he speaking on?
Just I
request Engineer Ramesh sir
to say a few words. Is there?
Okay. So let us carry out with the question and answer session, sir. I have a question from Prof.Ajay Simha, who is our faculty. Are the sections and connectors custom made as per the requirement of the design? For example, a capsule building.
Yes, these are completely built up structures. Capsule, if you take completely built up structures are there. So this is for the building requirement. Yes, it has been built.
Okay. And one more question from Ajay sir. Who designed these innovative methods?
Yeah, there are two persons are there. One is Aruna and another one is Anandraj. Anandraj sits in Dubai and Aruna sits in Chennai. So these are the two persons responsible for all this erection engineering.
Okay. Thank you, sir. And one more question from our student. Rather than steel and concrete, why we are not using any other tensile material which can support the structure?
It is based on the requirement. It is not used. So tensile structures normally will make a diaphragm. To take care of the diaphragm, we need a structure. So normally, if you take car parks or any canopies, there are diaphragm structures were there. But to support the diaphragm structure, we need a skeleton. So for that skeleton only, we are using steel or concrete.
Okay, one more question from our student Sriman, sir. While construction is going on the site, there would be more pollution which affects the neighbors or environment. As engineers or architects, how can we control it?
Yeah, that is where we are moving into steel. When you see steel construction, the carbon emission is very less. That is why everyone is emphasizing on green building concept. So when you get into green building concept, it is all about how much is the carbon you are going to emit. So for steel, it is a reusable material. Steel, the original material itself is reused, and the scrap of steel, again, it will be used back. So that is why the structural steel is highly predominant, and it is coming in the current construction industry. Steel is more predominant. So where steel pollution will be very less. When you take a composite structure, the concrete consumption comes down, the steel consumption goes up. So that means the pollution or the traffic due to huge trailers of cement or huge trailers of sand is cut down. There will be only few loads of RMCs or ready-mix concretes are going to be there. So by means of the pollution also will not be there, since there is no loose material going to be there. Okay, everything is pre-engineered and verified. We are going to just assemble it.
The next question says, the Three Gorges Dam, which is built in China, has slowed down the earth rotation. So by these large structures or high-rise buildings, are we interrupting nature, or it's our personal needs?
No, personal needs only, I have to say. It is every time for every purpose, we can see apart from a common goal, there is a personal goal also behind it. The personal goal cannot be an individual goal, it can be a community goal. For a particular community, that particular structure has been made, that's it.
So the next question is, how do the problem of corrosion in steel structures taken care, mostly which are built on the island countries, subjected to marine atmospheres?
So corrosion is the one which is highly against structural steel, and it has been sorted out say 20-25 years before. When you take the PhDs coming in structural steel 25 years before, most probably it will be from corrosion. But after those R&Ds, say 25 years before, we have beautiful technologies. The first one is 3-coat paint system. The paint system itself will be able to stop corrosion. So it will withstand about nearly about 20 to 25 years. It can withstand without any corrosion by means of paint system itself. Only touch-up paints, if we do, yes, it will go on to 50 years. Say, for example, we have Statue of Unity is there. Statue of Unity recently we built. For Statue of Unity, it has to be as per books, it has to withstand about nearly 100 years. So for 100 years, the surface protection has been given us. We have to galvanize, hot dip galvanizing. So once you do hot dip galvanizing of this particular structure, yes, surely as per theory itself, it will go beyond 100+ years. So corrosion is not an issue nowadays. And the another issue apart from the island, in the building sectors, it will come to the wet areas where there will be toilets, bathrooms, wherever we are going with the plumbing works, water usage works. So there are questions about the corrosion, but corrosion is nowadays has been taken out. So apart from a 3-coat paint system, we have vermiculite where we have it is applied for the corrosion and also for fireproofing. So both it can take care.
Okay, thank you, sir. Dr. Ramesh is asking a question. Can we visit your site while work is in progress?
Very well, welcome, sir. No issues. You're all welcome.
Karthik Patel from second semester is asking, what are the safety measures taken for the workers while construction of the structure is going on?
Yes, when you see the photographs itself, when anyone is doing bolting or welding at the top, tall one, there will be a proper scaffolding system will be provided so that they can properly sit without any danger. They will be made. And the next one is we will be having safety belts. So whenever you move on to the top, there will be safety belts you have to wear, and there is highly protected from falling from heights. So they are highly safety is the first most one. When I presented one, when I talk about the core values and vision about Eversendai, the first one is safety. Then it comes to quality, then client satisfaction.
One more question from Prof.Ajay, sir. How are the maintenance issues taken care of? Are there any other maintenance issues other than the corrosion?
Maintenance issue apart from corrosion is bearings. For example, these bearings, whatever we have designed, sometimes if it crosses this lifetime, what will happen? We have to replace the bearing. For example, we have seen the example of atmosphere. The building sits over 4 bearings. So there is a provision for maintenance itself. So every time you can go, you can visit how the bearing is there, you can go. The provision has been made. Also, the provision is made to lift the structure and to replace the bearing if it is worn out. So the provision is made to lift the structure, the complete structure. After any number of years, it can be lifted and it can be replaced. So those are the 2 maintenance will be required.
One question from Shreya. Sir, as you worked on the Statue of Unity, how was the experience while doing the largest statue of the world?
Sorry, Ram. Go ahead. Yeah.
So this is a question from Shreyas, sir. Shreyas of third sem. As you worked on Statue of Unity, how was the experience while doing the largest statue of the world?
Yeah, it is highly proud moment to be part of that particular structure, and we have been engineered it proper so that it can be done on time. When we take the proper timeline from the start to the end, it has been scheduled to open at the birthday of Sardar Vallabhbhai Patel, and the timeline provided for the construction people is very less. L&T is the main contractor and Eversendai is the subcontracting to them, and the timeline is very less, and everyone worked around the clock. And it is a very high, proudful moment to be part of the structure.
Sriman is asking, what is your opinion on the upcoming advanced building materials? Would they support these challenges, or should we always bind up with concrete and steel?
No, there are high-end structures are coming. For example, now corrosion-free steel is going to come. And without fire-resistant steel is going to come. And steel of currently we are talking about 350 grade and 450 grade. Currently we are ourselves are using 650 grades. 550 and 650 grades of steel currently we are using. There are R&Ds going until say 1500 kilonewton per meter square yield strength. So apart from that, there is various materials coming to reduce the weight and to increase the structure's strength. So there are high R&D and there are new materials are surely going to come.
Okay, one question from our faculty, sir. Mr. Shiva, is there any addition of factor of safety considered for erecting works, or is included in the analysis of forces?
Analysis, there are two types of analysis. One is during the main structure analysis will be as per the codal norm, say 1.4 or 1.6 factor of safety as per the relevant code we will be taking. And during the erection, the factor of safety also will be taken further to the original one. In addition to that.
There is a question from one of our students. How can an engineer look into the work process going on when it is in higher stories? Is there any way from inside like elevator to monitor?
Yeah, there are majorly in the tall structures, there will be elevators will be there. Okay, but sometimes you have to just climb up on the staircases with putting all your harnesses, you have to climb up.
One more question from my side, sir. Once the structure is completed with the bolted connection or a welded connection, still the structure will be subjected to transient wind loads during the entire life of the structure. So this may lead to the weakening of joints. How are they monitored? Are they monitored manually, or is there any system-based monitoring?
These are designed to take care of this fatigue. We call this fatigue, which is coming and going. Okay, for example, if the machine is there, then up and down movement will be there. Okay, so these type of cyclic loading, it will be designed for that. So there is no need for any maintenance during the design phase itself. These type of cycling loads are reversible loads. Okay, so those has to be during the design phase itself. We got to take care.
So that's all questions we are now having, sir. Ramakrishna, sir.
Yeah, tell me.
Sir, is Engineer Ramesh speaking?
No, actually, no. Engineer Ramesh is in a parking lot. So he says no. He has conveyed best wishes to students and Woxsen, and special wishes to Engineer A.Soundararajan.
Okay. So, Soundarajan sir is very great, intriguing lecture, and the questions poured in are also very intuiting. They are very much interesting, and you have very patiently answered all the questions and queries from all our faculty and students and participants. Thank you very much, sir.
Thank you, sir. Thank you.
Over to Prasanna.
Just a moment. Ram Kumar, sir.
Sir.
Now I invite Dr. Ramesh from Ar.Syed from Hyderabad to say a few words about the conference. Dr. Ramesh? Dr. Ramesh from Ar.Syed. Sir, Dr. Ramesh? Okay, over to Prasanna.
Thank you so much, sir, for your great insights. And now I would like to invite our Dean, Professor Ramakrishna Bushi, for a valedictory speech and deliberation. Sir, over to you.
Okay. Okay, thank you, Prasanna. First of all, I thank all the distinguished speakers who accept our invitation to be part of this conclave. And despite of their busy schedule and day-to-day schedule, and they accepted, and they delivered a very valuable insights to the students, and is valuable insights to not only the students but faculty also. So they really touched upon a very interesting topic we never come across also. So in a nutshell, I'll take this opportunity and present the 2 days deliberations of the conclave. So I just highlight a few points there. So when we first speaker Architect Syed Ahmed, and he has given a thought-provoking process to the students, especially if the temperature increases to 1 degree on the globe, and what will be the effect, and especially in the field of construction and architecture and engineering. That is a very great insight he has highlighted. And he also touched upon the carbon footprint and sustainability aspects and the process of innovation, especially in architecture. And especially the project called Interlace project in Singapore, and a very interesting project for the students. And he also highlighted the engineering technologies of container building and what are the advantages of it by using the container building. And he also given a small insight on the floating city which is already happened on the globe. And engineering saving aspects and shaping of the building, and at the conceptual level, that is very important insights he has given. At the conceptual itself, and what are the energy saving aspects one can consider, that is he highlighted. And our next speaker, W.I.T.Srinivasarao, and very interesting lecture, sir. And he spoke about different layers of the facade technologies and temperature variations at each layer, and what are the advantages of it. And he also explained to the students the facade technology versus the functionality. And he has also highlighted some points when students interacted with him. And he also explained the kinetic elevation and what is the implications of it. That is also he is highlighted some points, the very important points of it. And finally, our third speaker is a very excellent lecture by Engineer A.Soundararajan, and he has given an insight on marvels in the period over many periods on the globe. So especially, sir, your project CUPSARC structure given a more insight to us. A multiplane metal junctions. He has also given a more insights on multiplane metal junctions, deflections during the construction and after the construction. That is very important. And purpose of the shear wall. And that is also very important point he highlighted. And the metal decking and nodes with the 64 connections. That is very interesting to note. And geometry, the cantilever, curvilinear geometry, some aspects on the curvilinear geometry, which is new to our students. And erection engineering phase, he also explained some implications during the erection engineering phase. Very nicely explained some do's and don'ts while erecting the huge tall structures. And he also given a small insights on temperate towers. And very, 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 very thankful to all the three speakers to become a part of our conclave. And we are looking forward to your association for with Woxsen in future events and endeavors also. So thank you so much for this opportunity. Once again, I am very, very, very thankful to all three speakers. Thank you so much.
Thank you, sir.
Thank you so much to you.
All right. So now we could go ahead with presenting an appreciation certificate and respect of sir.
So you're on mute.
Right. Okay, I take this opportunity and to honor our speakers. So it is only a small token of respect and love and affection to the Woxsen family. So we present appreciation certificates to all the distinguished speakers. Please, now Mr. Shiva, please present. Sir, Syed sir, say a few words.
Thank you, Professor Ramakrishna, for reaching out to me during this time and giving this opportunity to exchange the views with the students. Students are always the future of the profession. So I think whatever ideas which we cannot implement at this stage, this is the time to transfer the knowledge to them so that they can start implementing in their future for everybody's benefit. And again, I like the way the program has been conducted. It's very well organized. All the faculty, moderators, and the vice chancellor, pro-vice chancellors, especially the students, it's quite a professional approach. I'm glad that this kind of quality is available in India, and of course, under the able leadership of all of you, I congratulate you for taking this to a very high quality, highest level of the education. Wish you all the best.
Thank you, sir. Thank you so much. Now, BT, please say a few words about the conclave and our students.
Well, what to say? I mean, it's great to indulge in such very qualified professionals amongst what we have looked at. All the speakers are excellently, presented their work, and more importantly, I really appreciate the students, the participation of the students, and the quality of questions. Questioning mind is the most important thing in what one can do. If you can teach a student how to think and question, that's really the basis of what knowledge is being passed on. And I appreciate the leadership in Woxsen School that is excellently doing in this work. And importantly, whatever I've seen in the moderators as well as the student presenters, I congratulate them to take up these roles as a challenge and then come together to hear us. It is not very often that students get to hear the perspectives of others on the other side, particularly from overseas. And as a student, we always wonder and then look forward to what is the technology and developments that are happening outside the perimeters of the borders. But I would appreciate also to look at inwards, because there is so much happening within India at the forefront in terms of development, innovation, creativity, using the natural resources, using what is locally available. That's really important, because our education altogether, as we know, is prone and developed to look forward to the outside India rather than inside India. I think this is very important to look into what we have and what we can use of our own resources in a way, so that we could develop local talents, local material technologies for the better use of architecture. And there are great leaders of examples like Charles Correa, my favorite architect ever, who's advocated on this forefront, and Convener, who's a great. These are the kind of gurus that transformed India into what India is now, and the students should take cue of that. And I thank the Woxsen faculty and students for giving me this opportunity, and I'm sure we'll see each other and talk more about the architectural forefront innovation. Thank you so much, Ajay and others. Thank you.
BT, just a moment. We would like to see, your creations at the student level. what you did to our students.
Oh, okay. This, sorry, Ramakrishna, you're talking about the student work?
No, this is no, your creation. So I'm inspiring my students.
Okay. All right. Thank you.
Please present second one. Please play second one once again. The first magazine.
Right, Ramakrishna, these are all the classmates. Cartoons are there. Thanks. Remember that.
You can see BT at a down, no? BT figure, cartoon.
Yeah.
Okay, this is mainly to inspire my students because they are doing working on a first release of a magazine, in-house magazine. So just I want to show because how our senior BT has done those days when technology is not available.
Yeah. I mean, technology is a tool, and I would really urge the students to look at what's available at hand is the most important thing. Don't make it an excuse that we don't have that or this. That's very important. You should start off and then jump into that with the use with what is at hand right now, and then proceed on that basis. And when you look forward, I don't have that technology to do something. That means you're putting barriers for yourself to do that. So when we started this magazine, it was more of an enthusiasm and collective work, and how students could come up with collaboratively, distribute their thoughts and communication. And for us, it did not really matter. We just went ahead and wrote whatever on the paper and found resources that are able to be circulated. So now, of course, you have much easier technology to distribute your communication digitally. So it's all your enthusiasm that matters.
Thank you, BT. Next, we will move on to Sir, Engineer Soundarajan, sir, say a few words about our Woxsen University and its conclave.
It's highly happy to be part of this conclave, and it is really terrible sorry for a third speaker to say a word of thanks, since already Syed and BT have given their best, and there is no words to say beyond that. So it is highly inspiring to work with you people. And this is the first time I'm giving a lecture to an architect. So I was worried about how to face out my speech, and how can I connect with the things, since normally architect I will put on my opposite side. But this time, first time, I have to put the architect on my same side and I have to talk. So I was a bit worried, but when I go through the questionnaires, it will be much better if I could come there and have a eye-to-eye contact. It will be much more better. But when I get through those questionnaires, I could understand that yes, fine, at least something people would have understood. So I'm highly happy and grateful to you all. Thank you.
Thank you, sir. Thank you so much.
I'd like to say a little bit about A.Soundararajan. Maybe he may not be knowing, but in the Middle East, when we look forward to have very challenging structures, ultimately we found Engineer Soundararajan and his collaboration and his company doing great work. So do not underestimate that being in India, you cannot. I mean, the works that are happening with his company are all over, and they are very challenging works. And we are glad to have you, sir, in the conclave.
Thanks a lot. Thanks a lot, BT. Thanks a lot.
Thank you. Thank you.
So,
Next,
and
yeah.
yes, sir, please go ahead.
Yeah. Please go over to you.
And with this, we would like to end our first Woxsen International Architecture Conclave 2021.
Much like the painted masterpiece,
The skin
the structural system
and sustainability,
plays an important role in architecture,
which is an art form that has the ability to
delight,
inspire.
and transform.
We immensely thank all our speakers for spending their valuable time with us and giving us a wider perspective on various aspects in architecture.
I would like to thank architect Syed Ahmed sir, who gave us some valuable insights on sustainable architectural innovations. We thank you from the bottom of our hearts.
I would also like to thank architect B.T. Srinivasarao sir, who gave us some great inputs on double skin architecture. It's not just about a beautiful facade, but also enhancing the structural aspects of it, which play a crucial role. Thank you so much, sir. We really appreciate your insights.
Now, I would like to thank Engineer Soundararajan sir for his wonderful presentation and inspiring speech, which grabbed our attention on the visuals of the structural aspects and challenges faced in the construction of architecture marvels.
We would also like to thank our founder and chancellor Veen Pula, Dr. Ahmed Badra sir, CEO Vishal Kurma, our Pro-Vice Chancellor Raul V. Rodriguez, and our Dean, Professor Ramakrishna Bushi, with whom this International Architecture Conclave wouldn't have been possible with.
I'd also like to thank Professor Ajay, Professor Ram Kumar, and Professor Shivakumar for their great support.
We would also like to thank the Dean of Technology, Dean of Arts and Design, the Administration Department, Technical Department staff, Woxsen Registrar, and all the professionals who attended this conclave. Also special mention to Mr. Lokesh Vanapalli, Mr. Suresh Mendon from Visual Communication Department, and Mr. Suresh from IT Department, and the marketing team.
Also, last but not the least, a special thanks to all the students who attended this conclave and made it a huge success. We hope you will continue the same.
But picture abhi baki hai mere dost.
Oh yes.
Woxsen School of Architecture will be back with another interesting conclave very soon. But until then, stay tuned, stay safe, and take care.
Signing off, this is Chandini.
And this is Lakshmi Prasanna Rao. Thank you.
Thank you so much. Thank you, speaker.
Thank you, everyone. Thanks.
Thank you, Soundarajan sir. Thank you so much.
Thank you, sir.
Syed sir, thank you so much.
Thank you.
BT, thank you so much.
We'll be in touch, sir.
Okay, thank you.
Sir, BT, sir, and Soundarajan.
Okay, we'll sign off. Okay.
Fine. Thank you.
Have a great day. Bye-bye.
Okay.
Thank you so much, everyone.
Thank you, sir. Mute. Sir, you're on mute, sir.
Yeah, thanks to all of you, actually. Thank the staff, thank you, students, thank you, anchors. You did very nice. And all the students, especially all the students, thank you for attending the session.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you all.
Thank you, sir.
Suresh, you should end the session soon, Suresh. I mean, or else we'll like leave.
Or you can start the class, sir. Ajay sir.
Yes, sir.
I won't find so many. I won't find so many students at the place.
Sir, on behalf of Conclave, when we are starting campus.
So,
Sriman is still on record.
Suresh, you should not. It's still on record. And but yes, they're looking at moving you soon to campus. We don't have a certain date yet, but definitely moving to the campus. Since we got it from the government also from first, but they'll be done in batches, so we don't know. We'll have
everyone got dates.
Yeah, you'll also get dates. Don't worry.